Let's construct the electric field for the case where we have positive charges distributed uniformly on a thin plate. So if we look at an area sufficiently away from the surface, then using the superposition principle we can visualize that the electric fields of two charges next to each other are going to have vectors that will cancel each other out. And similarly on this side, for example, you're going to have another charge where these vectors are going to cancel each other. And consequently what we get are the electric field vectors pointing upwards and downwards perpendicular to the plate. So using Gauss's law, we have the integral over a closed surface, and we're integrating the dot product between the electric field vector and the differential area vector, and that's equal to the total charge enclosed in that surface that we chose over the permittivity of free space. So by orienting the closed surface in this manner, we can see that the electric flux is simply going to be the electric field multiplied by the areas of the top and bottom of that cylinder. So that will be pi r squared, where r is the radius of the cylinder, and multiply by 2 to the top and bottom surfaces. And defining sigma, which is the areal charge density, which is in coulombs per unit length squared, while multiplying this by the area of the surface gives us the total charge within that surface. So that will be sigma by pi r squared. And we divide by the permittivity of free space. And now we can visualize that this area is going to cancel, and we end up with the electric field is equal to the areal charge density over 2 by the permittivity of free space. And this is at a distance sufficiently close to that plate and away from the edges where the electric field becomes complex. Now note that we could have chosen a surface with any cross-sectional area, so we could have chosen instead a rectangular prism, and then in that general case you're going to have this pi r squared being a general area, and this area appears on the other side of the equation also. So really have a think about that, and you can see that the areas are always going to cancel regardless of what cross section that we choose. And I'll see you in the next video.